Welcome students, today we will discuss about how to solve sphere problem using EDA technique. EDA means estimation of distribution algorithms. Estimation of distribution algorithms. So this algorithm by default it will perform minimization task. It includes 4 arguments. First one is EDA, it is an EDA instance. F, it is a evaluation function which is to be minimized, and lower and upper represents the lower vector and upper vector. And then finally, after executing this EDA algorithm, so the function is EDA run, you will get the output. It is a class, EDA result class having several slots or elements. So at EDA, at F, at lower upper, and the number of generations, at evaluation function, at best evaluate, best solution, at CPU time. So with the help of this output class, you can get any one of the values. Okay, let us see one by one the sphere function. This EDA algorithm is present in this library, so I want you to install this. So after loading this library, just execute it. So it is loaded, and the next thing is you implement the sphere function. So the implementation is already discussed. Sphere function is a sum over xi square. Okay. So let us execute the sphere function, and then the next thing is the dimensionality, that means how many variables in X. So let us suppose we are taking the simple problem, so we put the dimensional as 2, so that means 2 variables are there, and then the maximum number of iterations as 10, and then the population size, how many populations, how many solutions in each population, here LP as 5. So let us execute these 3 statements. So we executed. The next thing is you have to set the EDA type. So I want you to see the textbook. So just using the standard parameters, we have set the EDA type. Actually this is some sort of control list parameter which you will pass to the EDA algorithm. So I want you to pass it, the control list parameter. These are all standard arguments, and population size, and then maximum number of iterations. Let us execute it. So we executed. Let us take this statement. This statement is a set method function. So the purpose of this function is whenever the results are generated intermediately or for every iterations. So this function is used to store the results on the text files, temporary text files. So you can extract the data from those text files using pop function. Okay. So why we are doing this means we are going to plot the function. That is the reason. So we executed it. Next thing is we will run the algorithm by passing the arguments. First argument is EDA instance, okay, EDA instance act, okay, and then you have to pass the sphere function, and then the lower vector, that means in between minus 5.2 to plus 5.2, we have to find out the minimum value. So this has passed as a vector, lower vector, and this is passed as higher range vector. After that, we will execute this algorithm. So and then let us show the results. So you can see when you execute the show function, you can see what is the best evaluation function, how many generations, how many iterations, and how many function evaluations are done. What is the CPU time? Everything is shown. You want to find out the best value, you execute this statement. So you can see this E is a output class. With this output class, you can access its elements. E at best solution. This is the best solution, and its corresponding fitness value is represented here. So therefore, for sphere function, this is the optimum solution and its corresponding evaluated value. So output, you can see best solution and its best evaluated value. So result is a EDA class. So E is a class. With this class, we are accessing the elements, best solution and evaluation value. Okay. So you can see with this you can stop, or you want to plot the parameters, you can also plot. Let us run the statement. So if you see this, here we are having two parameters. We are plotting for first parameter actually. So we are reading the data from pop function, and then we are plotting on the tables. You can see the output here. X-axis represents the iterations and y-axis represents the values taken by that variable. So you can see this. You can also plot for second variable j is equal to 2. So you can see this output. You can plot for the second variable. In this way, you can execute the program and perform analysis. Okay. So just understand the function and pass the appropriate arguments. Thank you, students.